Hey everybody, this is Doc. This is our first lesson for Intro to Stats. I'm using the book Elementary Statistics by Navidi and Monk. It's the third edition. And what I'm going to do is, for the first chapter, basically go through the book with you. There's no need for me to write it out when it's right here. And if you have any other questions, you can let me know. This first video will cover section 1.1 and 1.2, which again is just a lot of information. So there's not going to be a lot of problem solving in these two sections, but we will get to that, I promise. So let's get started. Section 1.1, we're first going to look at the study of statistics. What is the definition of statistics? And statistics is the study of procedures for collecting, distributing, and drawing conclusions from information. So that is what we are doing. Now, the two things that we're going to be looking at whenever we're taking statistics will be population and sample. Population is the entire collection of individuals that you're interested in. And the sample is part of that population that contains individuals that you're actually going to observe or get the data from. So these are some very important definitions coming up. Now, you're going to hear a lot of ways that we can collect data and statistics, but by far the one that is accepted the most is the simple random sample. And the nice thing about the simple random sample is it is simple. So you're going to have a size n, which is the sample size that you choose. You might have 1 million people, but maybe you want a sample of 1,000. So n would be, little n here would be your 1,000. And you would choose them at random. Now, what does that mean? That means that every person or every item in that sample has the equally likely choice of getting chosen. Okay, so equally likely to get chosen, that would be a way of getting your simple random sample. Now, there's lots of different ways to get a simple random sample, and a lot of it determines on how large your population is and how large you want your sample to be. So this first one says you have 300 employees in a certain company. Human Resources wants to draw a simple random sample of 20 employees to fill out a questionnaire about their attitudes on jobs. So you could do this a number of ways. You can make a list of the employees and give them numbers 1 to 300. Then you can use a random number generator on a computer or on a calculator to generate 20 random numbers between 1 and 300. The employees who correspond to these numbers would comprise a sample. Now, if you get a chance, well, not if you get a chance, go ahead to Google. I mean, everybody should have access to Google. And type in there random number generator. And you'll find that there's a lot of things available to you online that you can do this with. If you don't have that availability at the moment and you have calculator for this course, they asked you to make sure that you had the TI-84. So the TI-84 allows for you to have a random number generator as well. So how you can do that is, it actually gives you pretty good instructions on page 9. So let's take a look at that while we go through it together. So it says first to enter a seed number, and this seed number could be any number that is a non-zero number. And the book chooses 21, and they said, well, they just looked down and saw that's how many seconds there were at the time. So there's really no rationale other than just picking a random number that is a non-zero number. And to press store, after you press store, then you're going to press math. Now it says then probability. Now my probability on this calculator is actually PROB, not PRB. And so do probability and then hit the number 1, which is rand. and then press enter. And this enters the seed into the calculator memory that allows for you now to start finding simple random samples. So if we go back to our example that we looked at, for the next one it says go ahead and press math, go back to probability, and then press 5. And see, I hit the number too quick, so I'm going to have to go back. See, math, probability, and then 5. Okay, now here I have upper and lower. You can see I was playing with this earlier because they had this example in here, numbers from 1 to 40. So let's go ahead and use that. I have a lower number of 1, upper number of 40, and I want 5 in my random sample. So I'm going to find 5, my lower number 1, upper number 40, and I'm picking 5 in my sample. I'll hit enter. Now let's say for some reason there's a problem with this. Let's say that there's double numbers in here, because it's the one thing that when you use a calculator, or if you even use a random number generator, the numbers might show up more than once. So let's say I have two 39s in here, and obviously two 39s aren't going to work for my example. I could just hit enter again and get another sample of 5. Now, this could be dangerous though too. You don't want to sit there and say, well, I don't really like those numbers that were drawn, so I'm going to do another one. Well, you'll be injecting bias into what you're doing if you did that. So you must have a logical math reason for not wanting the first 5 that you received. Okay, let's go back. Continue looking at this. All right, let's see whether or not we know that a sample is random or not. This one says a physical education professor wants to study physical fitness levels of the students at a university. There are 20,000 students enrolled. She wants to draw a sample of 100 to take a physical fitness test. She obtained a list of all 20,000 students numbered from 1 to 20,000. She uses a computer random number generator to generate 100 random integers between 1 to 20,000 and invites them 100 corresponding students to those numbers to participate in the study. Is this a random sample? It certainly is. Okay, so it certainly is a random sample. Everybody has an equally likely chance of being chosen. Now, let's say this professor is being a little bit, well, I don't want to say lazy, but we'll say wants convenience, and has a class of 50 students fill out a survey because he wants to know what sports they play. So instead of getting a random sample of all of the 20,000 students on campus, he just walks into his 10 a.m. class that has 50 students in it, and he uses the first 20 minutes of class to have them fill out the questionnaire. This is not a random sample. This would be something that is just convenient for him to do because they are all right there. And a lot of times convenient samples are not looked upon as very quality samples. So sometimes it doesn't matter, and we're going to take a look at that in a couple minutes. But for this example, it would be frowned upon for sure. Now, sometimes you have to take a look at whether or not in a simple random sample, all the samples are equally likely. To play the Colorado lotto game, you must select 6 numbers from 1 to 42. Lottery officials draw a simple random sample of 6 numbers. If your 6 numbers match the ones in a simple random sample, you win the jackpot. Sally plays the lottery and chooses numbers 1, 2, 3, 4, 5, and 6. Her friend George says that this isn't a good choice since it's very unlikely that a random sample will turn up the first 6 numbers. Is he right? No, he actually is not right, because if each of these numbers have an equally likely chance, then it's equally likely they could be chosen that together. Now, it might seem like that's unlikely, but it's unlikely that any combination of 6 numbers that you would choose would be chosen. So you have the same amount of chance of putting 1, 2, 3, 4, 5, 6 and getting the numbers as you would put any other numbers. So she has the same chance as anyone else to win the jackpot in this situation. Okay, so here's the next one, using technology. We actually already did this. Here we have 40 people, and we want to use the calculator random generator to pick. So anytime you have a number of people, you can, or a number of things even, you can number them, give them, assign numbers to them, as long as you have a way of choosing those numbers in an equally likely way. That's okay. And this way we did it with a calculator, and it would choose these numbers. Now here in the book they have 27, 39, 30, 35, and 17. What does that mean? That means you're going to come up here. 27 is Laverne, 39 is Lisbeth, 30 is Gary, 35 Sherry, and 17 Andrew. So that's how that corresponds. All right, so far pretty simple, right? Let's check our understanding. A pollster wants to estimate the proportion of voters in a certain town who are Democrats. He goes to a large shopping mall and approaches people and asks whether they are Democrats. Is this a simple random sample? Yes or no? Okay, what do you think? I don't think so, because he's going to the mall at a certain time of day, and there could be certain types of people that hang out at the mall at certain types of day. For instance, if he went on a work day during the afternoon, if the malls were open, he could more than likely would have a group of elderly people, because they like to go to the mall in the afternoon. It's kind of a gathering place for them. So that would not be a simple random sample. He might go to the mall on Friday night when there's a lot of teenagers hanging out, and would ask them. And so that way it is, again, not a simple random sample. Not everybody has an equally likely chance of getting chosen. Now, a telephone company wants to estimate proportion of customers who are satisfied with their service. They use a computer to generate a list of random phone numbers, call these people and ask, is this a simple random sample? And yes, this is a simple random sample. Even though calling people on the phone to ask them is not always a good way, but that's not what we're talking about here. Right now we're talking about whether or not choosing those people were chosen at random. Okay? Now, in some cases it might be kind of impossible or very, very difficult to do a simple random sample. And when that's the case, you may have to do a sample of convenience. So when would this happen? Well, here's this example here of a construction engineer receives a shipment of 1,000 concrete blocks. They all weigh 50 pounds each. The blocks are delivered in a large pile, and he wants to investigate the crushing strength of the blocks by measuring the strengths in a sample of 10 blocks. So why might it be difficult to do a random sample? Well, I don't know about you, but I'm not going to really want to go to the bottom of that pile and then number all the blocks and then choose a random generator. That would be an awful lot of strain and work, especially when, in this case, we can take a look at these and realize that these were all probably kept from the same mold. So there really is no reason to not just pick the 10 on the top. It would kind of be silly. So we can just do that. Another example would be, let's say you have a bag of regular M&Ms. And get them all out, line them up, or you're just going to reach a hand in and grab some of them that are convenient for you. Well, in that case, and in this case, both of these things are made the same way. There's no distinction really in how they're created. So it would be okay. So how would you know when it's okay and when it's maybe not okay to use a simple random sample? Well, they give you a summary here, and they just said it's acceptable and reasonable to believe that there's really no systematic difference in the sample in the population. So the question here is, what they're saying is there really a difference between the block on the top and then the block on the bottom? No, it's not. So then it's fine to use a convenience sample. And the other way is it's not acceptable when it is possible that there is a systematic difference in the sample and the population. So if you're talking about individuals, each individual is different and they're definitely have different characteristics. So it would not be a good time to choose a convenience sample if you were talking about individuals. Okay? All right. Moving right along. Stratified sample. Now, stratified sample is when there's some kind of reason that the population should be put into two groups. Okay, so for instance, let's say here they talk about having 100 or actually 1,000 employees, but some of those employees are full-time and some of them are part-time, and they want to do a survey about their opinions regarding benefits. Now, full-time employees and part-time employees might have a very different stance on how they feel about benefits. So in this case, you would want to separate them first. Separate 800 group and separate the 200 group. And then from each of those groups, do a simple random sample and say, here's how my simple random sample of 800 full-time feel about these benefits. And here is how my 200 employees, a simple random sample of them, feel about the benefits. So that would be called a stratified sample anytime there seems to be a need to separate them into groups according to some kind of attribute. All right, cluster sampling is drawn from a population or clusters. So a sample, when a population is too large to go out and spread, the simple random sample being feasible. So what do you mean by that? Okay, so let's say we're talking about households and we want to go through and we want to get the opinion of households. Well, if we take a cluster sample, we take a household and each person in that household we check. We can do that. That would be considered a cluster. So estimating the unemployment in a country, a government agency will draw a simple random sample of the households. And then they will visit each household and ask how many adults are in the household, how many of them are unemployed. So here, this is where you're talking about having your clusters would be the group of adults in each household in the country. And it's a simple random sample because you still used an SRS to choose the households. But once you got the households, you use the cluster in that household to get your information. Systematic sampling. This reminds me of when I was a kid. We used to, for gym class or for doing teams, the teacher would say, line up everybody, and they would go through and say 1, 2, 3, 1, 2, 3, 1, 2, 3, and give everybody a number. They'd say, okay, all the ones come here, all the twos go there, all the threes go there. That's an example of systematic sampling where you're going to be ordered and you might do every other one or every third item or every fifth or every 100, something like that. So that would be considered a systematic sample. The last one we're going to talk about is the one that really isn't any good for hardly any situation I can think of. Voluntary response samples. And this is the one that is used the most. And it's really used a lot by media. It's used a lot by people who want to get opinions in a certain way. That's the voluntary response samples. Now, why are they no good? They're no good because of this reason. If somebody is volunteering to give you an opinion, that generally means their opinion is very strong about whatever it is you're asking about. People who really don't care about the opinions are not going to take the time to give you their responses. So you might say, well, why does that matter? Well, it matters because you're not getting a picture of how everybody feels. You're only getting a picture of how people who have strong opinions are feeling about those topics. So, as they say here, voluntary response samples are never reliable. One of the examples of this are the political mailings that people will get in the mail. If you have a Republican household, you'll get a lot of Republican surveys. If you have a Democratic household, you'll get a lot of Democratic surveys. and they will say, please tell us how you feel on these items. And those items might be hot topic items such as maybe gay marriage or maybe abortion or those kind of things that people generally have a strong opinion about. And the only people who will respond to those are those who want everybody to know about that opinion because they feel strongly about it. So that would not be a good way to get everybody's opinion. Okay, now this last part here, I think this is the last, oh, not quite last. Okay, so this next part here gives you an example of what it would look like if you're more of a person who likes the pictures versus all of these words. This is an example of a simple random sample. You see there's no pattern here. They're just chosen at random. Systematic sampling would be, here I'm going to go with every third row. That would be systematic sampling. A stratified sample you see would be, you have one group over here and one group over here. They're split apart, and then you're going to do an SRS on this side, and then you're going to do an SRS on this side. SRS being simple random sample. And finally, a cluster sampling would be if you're going to just choose household at random, and then you take everybody in that household and you take everyone in the household and then get their opinions or whatever the data is that you need. Okay? All right, so that gives you a little bit of a picture of what that means. Now let's take a look at statistics and parameters. Now, statistic is a number that describes a sample. So when you say, well, what is the statistic on how many cavities people will get when they use Crest? Okay, so that would be data taken from the random sample that was chosen. So a statistic is a number that describes the sample. Then after you get that statistic, once it is checked out to be reliable, then that number may be used to describe the population, and at that point it becomes a parameter. So a parameter is a number that describes a population, and a statistic is a number that describes the sample. Okay, well that's all for section 1.1. We are going to go to section 1.2. Section 1.2, we're going to talk about data sets. Okay, here we have data sets. So we're going to look at collecting information by sampling. Once the information is collected, then we say now we have a data set. Now we have our data. So table 1 illustrates some of the basic features found in most data sets. So this one gives how many students we have, their majors, their exam scores, and their grades. So in many cases, the individuals are people, but they don't have to be people. Individuals could be plants, could be animals, could be things. The characteristics of the individuals about what we collect are called variables. So in this example, a variable would be the major, would be the exam score, and would be the grade. And the values of those variables obtained are data. So for example, the data for the individual number 1 would be his major is psychology, exam score is 92, and he has a grade of an A. So the data would be here, and the variables would be the titles, the major, exam score, and the grade. Okay. Now, we're going to talk about quantitative versus qualitative variables. Quantity means an amount. Anytime you hear the word quantity or quantitative, then what you can say is it can be measured. So it's something that can be measurable, and it's something that can be counted. A qualitative gives you individuals to be put into categories. So you might say, I want all the red M&Ms in this pile, the green M&Ms in this pile, the brown M&Ms in this pile. Those red, green, and brown would be qualitative variables, which classifies them into categories. So, as you're looking at this, qualitative are called categorical variables. An example could be college major, could be gender. Quantitative variables are numerical and may tell how much of something there is. Now, height can be quantitative, a score in an exam can be quantitative, so it's some kind of measure generally. A person's weight can be quantitative. So let's take a look at what we have here and distinguish between quantitative and qualitative. Okay, so first we have a person's age. Person's age is quantitative because as you get older, it's a measure of how old you are. Now, this is kind of funny, a personal thing. I just had a birthday and I just turned 52. But the funny thing is, I have been telling people for the last year that I'm 52 without even paying attention. So this year when I turned 52, just this past June 30, my friends decided now for this next year that they're going to say I'm 51 because I decided to skip that age. Now that wouldn't really be accurate, but anyway, just thought about that. Gender is qualitative because it's just in a category of male, female, or other as we take a look at these days. Mileage is quantitative. It tells how many miles a car will go on a gallon of gasoline. And the color of a car is qualitative. You separate them into maybe blue, red, green, orange, yellow, black, white. Okay? So those are distinguishing between qualitative and quantitative. All right, let's look at ordinal and nominal variables. Ordinal and nominal variables. An ordinal variable is one whose categories have natural ordering. So think ordinal, ordering. So if we're looking at grades such as A, B, C, D, or F, that would be an ordinal variable because they have an order. We look at that and we say, oh, an A is really good, a B is less than an A C is less than a B, a D is less than a C, and an F, that's not so good. So we automatically would classify those in that order. Now, a nominal variable is one where the order doesn't matter. It has no natural ordering. So that would just be a nominal variable. So let's take a look at the difference between nominal and ordinal. Let's say if I asked you what state of residence that you lived in, assuming that you are a United States citizen, or let's say even if you're not, where are you staying in the United States? The state of residence would be nominal. There's no ordering to our states. What is your gender? Gender would also be nominal. There's no specific order that is considered. One might be better than the other, or one might be before or after the other. Now grades, A, B, C, D, or F, as we talked about already, are considered from high to low, and so that would be ordinal. And the size of a soft drink at a fast food restaurant, small, medium, and large, that would be ordinal as well because that is a size. So we know that small is going to be the smallest, medium is going to be in the middle, and then large will be bigger than the other two. Okay? So those are your ordinal or nominal variables. Now, let's take a look at discrete and continuous. Now, we will be dealing a lot with discrete and continuous in this class. So it's really important to know the difference. Discrete basically means you can count it. It can be put on a list. There are a certain number. It's a finite number. So anytime that we're talking about discrete, that means I could count them. So let's say I'm a shepherd and the sheep are coming in at night. I'm counting them 1, 2, 3, 4, 5, etc. coming through the door. Now, continuous variables could take on any number in an interval. It could be an infinite amount of numbers. And we would say height would be an example of that. And you might say, well, height, how is that So, well, if I measured somebody and they might be, let's say 68 inches, or maybe they're 68.1 inches, or maybe they're 68.1452389 inches, then you can see there's an infinite number of possibilities even between 68 and 68.2 here. So that would be a continuous model, So discrete variables are quantitative variables whose possible values can be listed. The list might be infinite, maybe all the whole numbers, but we could still count them. Continuous variables are quantitative also that can take on a value in some interval, but there is no restriction to any of the lists. So there's an infinite number in all the lists. So that's how you can know the difference between discrete and continuous. So here we go with A. The person at his age of her last birthday. Well, as long as they know when their birthday is and how old they are, and like myself, then it would be discrete. A height of a person would be continuous because it'd be a lot of list of values. I have a lot of international students that stay with me. They come and they play basketball. So believe me, when we're talking about height, they want to measure to the very tiny little difference. And number of siblings that a person has would be discrete. And the distance that a person commutes to work would be continuous because it's not restricted to any list of values. Okay? So that would be all of section 1-2, believe it or not. So that one was pretty quick, but nonetheless very important for you to understand these differences. So the next video we'll go over section 1-3 and 1-4, and hopefully you were able to stay awake in this video, and I will see you soon. And as I always say, peace out.